everyone, my name is Óbuda, and this is my official unofficial solution for the network state exam. Now it's about the 22nd topic, which is about traffic filtering mechanisms. The concept, condition, and implementation possibilities of traffic filtering. Of course, here you can come up with the different possibilities because that's the different possibilities. Oopsie, sorry. That's the different possibilities. So, for example, of course, we can use intrusion prevention systems, intrusion detection systems as well. We can use firewalls. These can be, for example, host-based or dedicated. So there are a lot of stuffs, and the most simple one is using a traffic filtering mechanism is the access control list. With this approach, we are simply filtering layer 3 and layer 4 traffic. So basically, that's the concept, the condition and implementation possibilities. I don't know what the condition, I believe, is having the network and able to use these approaches, and I believe that's all. So this topic is about access control lists. Here we have different approaches or implementations considering the access control list, and the first one is simply define the in or outbound of an access control list, or what does it mean. So everyone knows that if we get paint, then let's have a router, because we are talking about layer 3 or layer 4. So this is a router, and of course we can have inbound. So this will be the inbound, or here will be an inbound access control list, and we can have an outbound access control list where the access control list will be placed on the outbound place. So what does this exactly meaning? Imagine that we are using an access control list on the inbound side of the router. That simply means that the traffic will be filtered before it will be passed to the router. So it is quite easy. It is good because in this case, if the traffic will be discarded, then the router does not have to look up its routing table and forward the traffic, so the router will not use CPU for that approach. And for example, on the outbound access control list, or the outbound access control list was simply discarded, so it was just a waste of resources, and this can, for example, bad. So this is a good example that why you wouldn't use it. For example, why would you use? But yeah, as a contrast of it or with it, we can come up with the example that imagine there are, I'm going to do it with purple, there are multiple connections to the router. Like imagine we have just 10 interfaces connected to the router, and imagine that we are not going to place to all the inbound and access control, the same access control list, for example, because that's a waste. In that case, we are using the outbound approach, because in that case we would like to have the router to check its routing table, because we are not going to implement an access control list 10 times, for example, on the same interface. If there is a single output interface of that, of course we will put the access control list to the outbound interface, where the 10 interfaces the traffic that goes through the 10 interfaces will be filtered on a single interface. So in that case, it is more worth to use an outbound, for example. So it's a vice versa. It can have advantage or it can have disadvantages as well. Okay, so I believe that's the implementation possibilities, the basic of the access control list. Of course, no, we are going to talk later about standard and extended. So the configuration sequence of the access control entries, because an access control list is consisting or is a several permit and deny statements that are called access control entries. So if I remember well, maybe these have numbers, so the sequence is really important because come up with another example that we have, of course, here the router is not that important, we are looking for the traffic in this case. So the traffic comes here. There is, for example, an inbound access control list here, and what that will check, because we are talking about layer 3 standard access control list. So in that case, we will check the IP addresses. So how is it going to look like? Of course, we have a source IP, we have a network header, a transport header, and a data at this layer. So here we have IP. Here we have a transport header, for example TCP, and here we have the actual data. I'm going to write it out. Data. So what's going to happen? For example, if there is an access control list that permit, I know it's really nice. Permit, and for example, we are defining a host, and after that we have a deny, and after that we have a host address. It's important, address, and here we have a host address and a subnet mask as well. So what's going to happen in this case? For example, the access control list for first will check whether, for example, the IP address is 182.168.10.1, and if yes, then we will permit, let it in, and if not, then we will go down and check the next access control entries. So we are fulfill this. Imagine, as I said, there are two solutions: permit, we go forward, or denying, we are going to a lower one. So next one, we will check whether it's within a host, because within a subnet, because we are giving a subnet. Here I only added a single, I'm going to visualize it. Here we added a single host address like here, so we are simply checking the host address, and here we are also adding a subnet mask. Therefore we are checking whether we are not giving a single IP address but a IP address within a subnet mask, so we can have multiple IP addresses here. So for example, we can check whether this is let's say 1.0, because we have add subnet mask. So anything that, for example, the next 255 IP addresses can be permit now denied, so we are denying by default. And it's important that if we are not that 255 IP addresses, then we are permitting. So it's a simple permit and deny statement. You can come out or come up with examples like this, that we are doing these several approaches, and basically that's all. So what else do we have here? The sequence, the access control list types, the configuration steps, usage and purpose of wildcard mask, the operation and testing of access control list illustrated with concrete examples. Okay, so the purpose of access control list, for example, we can come up with another simple example that we have this router that, for example, will be the inside the intranet. We have other routers. Here comes something, these are connected, and these are connecting to, for example, hosts. If we'll draw this host, then what can we say about this? So this is the untrusted network, and this is the trusted network. For example, we have put an access control list here, or we can put here. Let's do it with another color. Let's do it with yellow, and let's do one more with blue. So for example, imagine that it's common at every big firms or companies that people are not allowed to do anything while they are at their working place. I mean, they cannot, for example, look for stream videos, or they cannot use Facebook, cannot surf on the web. Therefore, the purpose of access control is simply denying or permitting these traffics, because access control list is operating at layer 3, and at layer 4 it means that it is stateless, which means that these at the access control is actually just checking the traffic, and they cannot determine whether whether the current traffic is belonging to the previously examined traffic or not. So it does not handle sessions, it just simply checks packet by packet and checks all the criteria that's defined in the access control entries. So for example, here with the purple, we can define that no HTTP service is available, so no web browser is accessible by our hosts within the network. Or here with the blue, we can say that this guy cannot use SMTP services, or this guy, I don't know, cannot use something else. And for example, here with the yellow, we can let the boss to do almost anything. So it would be more accurate to not put here this purple one, but putting here and say that he's the boss, and the HTTP traffic can go into this direction, but cannot go to this direction because it's filtered here. I mean, not here, but here. So it's a quite good example that you can come up, or you can come up with other examples. So what do we have here? Access control types, which is important, of course, that we can have standard and extended access control list. The standard is the basic layer 3 traffic filter approach, because there we only using the source IP address, and we cannot define more. I mean, here, if I remember well, that's not that. Let's do a new one. We are not defining there, for example, access control is 1 permit host address. That's a simple host IP address. That's a simple or standard access control is, because there or here we are only defining some simple solutions. We cannot do anything more that's more extensive. And of course we have the extended, which is better, because there at the extended, as I drew up previously, we have a source and destination IP. Let's say it's SIP, and let's say no, not S, but DIP. That's in the network header, and there is a source port, and there is a destination port at the transport header, and of course there is the data that we currently is not using. So layer 3 only uses this one, layer 4 uses both of them. We can filter based on the source and destination IP address, and we can filter based on the source and destination ports and services as well. So if I remember well, extended is something like access control is 1 TCP permit host IP address, for example subnet, equal, and here HTTP, or if I remember well, we can define not just the service, or instead the HTTP, we can say the port number, which is 80. So this is an extended one, and from this previous example or picture you can define it. Here we can filter based on more approaches, therefore we can do much more stuff. Of course, it is important to emphasize that a standard access control list is easier to implement and install because it consists of simple access control entries, but an extended can do more and more advanced stuff, but it will require more knowledge and can be hard to administrate after a lot of time. So if we are having more and more, then it can be hard to administrate. So I believe that's all about the types and the configuration steps, because configuration steps you are just simply defining this permit and denies entries. The usage and purpose of wildcard mask. Okay, it is quite important that we have the original wildcard mask, that we have an IP address and we have a subnet mask, or no, let's write it here. It has a subnet mask as well. And of course, the subnet mask will determine, I mean, not the subnet mask, the machine, the computer with the logical ending will determine that with the help of the subnet mask, which part of the IP address, which of the IP address is the host portion and which part of the IP address is the network portion. So here the subnet mask is something like this but different. So the wildcard mask is simply is that we are having zeros and not ones. So the zeros means that we would like to match those bits, so those bits should be examined. So we are having the subnet mask, it's called as the inverse subnet mask, and here it simply defines that which bits should be matched and examined. That's all about the wildcard mask. The operation and testing of access control list. If I remember well, at access control list there is a statistics about how many traffic has been managed. I mean, how, for example, if we deny IP traffic, then if I remember well, we can check how many IP traffic or packet had been denied. So in that way, we can check the operation or the testing of it, and basically I believe that's all about it. Static and stateful traffic filtering. It is quite important that I said access control lists it's not static, I guess it's stateless, or I totally didn't understood well, but the stateful means that we are handling sessions as well, so we are having layer 5 involved, but access control lists are at layer 3 and 4, and as I said, that means that we are not handling sessions. So the difference would be if we would have a traffic filter mechanism that could handle or that would use a layer 5 as well, is that in that case we could tell that whether the traffic, the packet that now currently being examined or filtered is belonging to the previous data or not. So in this case, if we would be stateful, then we could determine whether we are at the data initiation, data transfer, or communication initiation, data transfer, or a determination state of the communication. As I said, we are involving layer 5. If we are stateful, that means we have a session table, and somehow, I don't know how, but somehow we are checking, or the filtering approach that can use layer 5 is having a knowledge about the session table, because here we are talking about tables and get something about that table. So that's the difference between them. The structure and operation of Cisco standard and access and extended access control lists. Okay, I spoke about them. Concrete example, I believe you don't have to do this many examples. Configuration of extended access control lists. TCP, UDP, I said I wrote one with TCP. You can of course do something like UDP. If you do exactly the same, then you will say that not TCP but UDP here, and for example SMTP, which of course is at the port 25. And you can do with ping that, for example, with ping with ICMP packets as well, that we are not allowing, for example, pings in the network. Okay, the placement of the standard and extended access control is, it's quite easy. That I said at standard we are checking the source IP address, therefore it is more advisable to put it as close as possible to the destination, to the destination. And the extended is the opposite of it, because there we can examine everything. It is more advisable to put it as close as possible to the source. Verification of access control list operation. I've said that stuff that I believe we can check how many traffic we are capturing and, for example, blocking. So I believe that's enough for this topic. And again, if I said something wrong, then I don't really care. And don't forget to subscribe to my channel.